Hello and welcome to this video where we're going to explore the mathematics of quantum mechanics. Now, quantum mechanics is a fascinating subject and it's based on two main principles. The first one is wave-particle duality and the second one is the uncertainty principle. So, let's start with wave-particle duality. Wave-particle duality tells us that all particles in the universe can behave as waves and particles at the same time. This means that depending on the experiment that we conduct, the particle can act like a wave or a particle. Now, this might sound strange, but it's a fundamental principle of quantum mechanics. Now, let's talk about the uncertainty principle. The uncertainty principle states that we can never know both the position and momentum of a particle with absolute certainty. So, the more precisely we know the position, the less we know about the momentum and vice versa. This principle is not just a limitation of our instruments, it's a fundamental principle of the universe. Okay, so now that we've talked about these principles, let's move on to the mathematics of quantum mechanics. The mathematics of quantum mechanics is based on complex numbers and matrices. This is a departure from the traditional mathematics based on real numbers and vectors. Now, the most important equation in quantum mechanics is the Schrödinger equation. The Schrödinger equation describes how the wave function of a particle changes over time. The wave function is a complex-valued function that describes the probability of finding a particle in a particular position or momentum. The Schrödinger equation is a differential equation, which means it involves derivatives. These derivatives represent the change in the wave function over time. The solution to the Schrödinger equation gives us the wave function of the particle at any given time. Now, the wave function alone doesn't tell us everything about the particle. We have to extract more information from it. One way to do this is by calculating the probability density. The probability density tells us the probability of finding the particle in a particular volume of space. Another important concept in quantum mechanics is superposition. Superposition tells us that a particle can exist in multiple states at the same time. The wave function describes all these states simultaneously. When we measure the particle, we collapse the wave function and get a single result. This is known as the observer effect. Lastly, let's talk about entanglement. Entanglement is a phenomenon where the states of two particles become correlated and dependent on each other. This happens even when the particles are far apart. Einstein called this phenomenon spooky action at a distance. Entanglement is a fascinating topic and is being researched extensively by the scientific community. Okay, that's it for this video. We hope you enjoyed learning about the mathematics of quantum mechanics. It's a complex subject, but it's also fascinating and mind-bending. If you have any questions or comments, feel free to leave them below. And as always, thank you for watching.